Hello everyone, this is Maths Guy channel here, and today we are going to be going through linear functions. Okay, so before we begin, we need to understand what a function is. And a function, a good definition that I found of a function, is a set of ordered pairs in which each x value is paired to a unique y value. Each x has a unique y value. Okay. So the functions also have this trait called correspondence, which is the type of pairing of how each x has a unique y value. It is called the vertical line test. And what this test does is that, in theory, if a vertical line going, so let x equal some constant, goes through the graph, you would hit at most once. And if a function satisfies this definition, it has a one-to-one correspondence. Later on, perhaps we will go through different types of correspondence. But another trait of functions is the domain and range that they have. So a domain is the x values that the function can take in or accept, and the range is the same but for the y values. However, in practical applications, sometimes the domain needs to be restricted. For example, such as things like a negative distance or negative time, which we know simply can't exist. Okay. So a gradient of a gradient of a function refers to its sort of steepness. Steepness. Not sure that's a word, but I think the analogy is there. And it's usually in the form of m, which is calculated as the y coordinate of one point minus the y coordinate of another point. This is then divided by the x coordinate and the y coordinate. I think it's one of the ways to visualize this is by going to called Desmos. So here, let's say for example we have the function 0.1, 1, and we have the point 1, 2, 2. Oh, sorry. 2, 4. Okay, that's a better example. Okay. So the steepness is by subtracting the y coordinates here. So 4 and 1, so 3, and 2 minus 1 is 1. So it tells me for these 2 points, the gradient here is 3. Okay. The properties of gradients, or some properties, is that for 2 lines to be parallel lines, the gradient of one function has to be the same as the other function. And for perpendicular lines, the gradients m1 times m2 equals -1. So a linear function is in the form of y, or f of x equals mx plus c. And just to show it here, mx plus c. Okay, so in its general form, just gonna get rid of this for now. Y, in the simplest form, the function is the basic form y f of x equals x. So y equals x. Okay, so this is the sort of steepness I was referring to. So if you take 2 points, so the gradient here, let's say if we take 2, 2 and 4, 4, you would get a gradient of 1, which is satisfied, just shown here. If x squared, I put a 1 in front of it, nothing really changes. Go back to the general form, mx plus c. So, let's just set this right now, but like here, as you can see, the c is the constant that moves the graph up or down in the y direction. Let's see, so 0 here, let's compare to 2. And this 2 is reflected here, the y-intercept. The m is the gradient in this case. Then, as you see, as the number increases, or rather goes away from 0, the slider is limited at 10, but we can generalize it to a number that's further away. It is steeper towards the y-axis. Whereas if it is less than 1, we see that it approaches the x-axis. When the gradient is negative, it flips. Graph flips, and even towards negative infinity, this gradient still possesses its steepness. Okay, so another property function is finding the midpoint. So, as the name suggests, if we get some coordinate 1, 1, and 2, 4, let's say, there's a coordinate in between here, and you're able to find this out, and this is calculated by the formula. The average of the x coordinates so that would be its x value, and the y value would be the same. So y 1 plus y 2 all over 2. The distance formula. In a linear function, as you can see, if we complete this, you can see a right angle triangle is formed. And so, to reflect Pythagoras, the distance formula is the square root of the difference between the x coordinates, all squared, plus the same for the y coordinates. This should be square root. And that's the introduction to linear equations. That'll be all.